this is a generational good. This is something that will outlive me and outlive my efforts. Make sure we do it right, we do it responsibly, and we do it ethically.
I am a big fan of science, and I'm a big fan of the use of data to do big science.
Welcome to our South by Southwest panel. 55 million human tissue samples plus artificial intelligence equals better medicine. Hi everyone, I'm your host today, Scarlett Swerdlow. I'm a data scientist at the Defense Digital Service. We are a SWAT team of nerds in the Office of the Secretary of Defense. One of the amazing projects that we were brought in to help transform is an effort to modernize something called the Joint Pathology Center, the world's oldest and largest repository of rare pathology specimens. I'm very excited today to be joined by some of our collaborators in this monumental effort. And we're going to be talking about how modernizing this repository will help improve the diagnosis and treatment of disease for service members as well as for the population at large. We have a lot to cover today, from computational advances in medicine to digital infrastructure, issues around ethics and machine learning. So we are going to jump right in. And to start with, I'm going to ask each of our panelists to introduce themselves, starting with Colonel Joel Moncur.
So my name is Colonel Joel Moncur. I am a doctor in the Army, and I serve as a pathologist. I'm subspecialized as a molecular and genetic pathologist. I'm also the director of the Joint Pathology Center in Silver Spring, Maryland, and I'm delighted to speak with you today to take part in this panel about the Joint Pathology Center's digital transformation project. Thank you.
Hi everyone, I'm Faisal, and I'm an assistant professor here at Harvard Medical School and the Brigham and Women's Hospital, and my laboratory works on computational pathology and using artificial intelligence and deep learning tools to use a lot of pathology data and develop tools that can help pathologists.
I'm Ellen Clayton. I am a professor of pediatrics, health policy, and law at Vanderbilt University and Vanderbilt Medical Center. And I have spent much of my career working on the appropriate use of data and tissue samples for research.
I'm Stephen French. I'm a digital services expert at DDS, where I'm the principal engineer and cloud architect for the JPC Pathology Digitization Project. And I'm speaking to you today from our beautiful offices in Augusta and Tatooine. But I live in Atlanta, Georgia.
One of the things I love about this project and this panel is that each of you comes from such a unique background and a different perspective on this effort. I'm hoping that each of you could tell me kind of what brought you to this virtual conversation today, and what specifically you're passionate about when it comes to this effort.
People in my position, doctors that serve in the military, really have an intense desire to serve. And I think that this project is extremely exciting to me and our team, because it just represents an enormous opportunity to have a very positive impact on the military and the patients that we serve in the federal government. The military was enormously thoughtful in creating this institute in 1862. So the Joint Pathology Center, which we would call the JPC, is a historic military institute that really has a team of expert pathologists that help pathologists across the world get to the right diagnosis for their patients. If we were on that TV show, Who Wants to Be a Millionaire, we would be the phone a friend option because we're your most knowledgeable friend that can help you get to the right answer. Tissue samples come to us, and our pathologists look at those underneath the microscope and come to the correct diagnosis for those patients. The cases that we receive, we actually keep, and they've built up into the largest repository of slides and tissues in the world. It started off in 1917, so it's 104 years old, and it contains a whole host of both common and uncommon diseases that are, as mentioned, really a treasure trove of data. We do believe that in the modern era that this is really an unrivaled source of high quality data that can be used for machine learning algorithms. And so we think that's really just an enormous benefit. As a small example of the types of things that are in that repository, there are tissues from the 1918 pandemic, from the Spanish flu pandemic, and those were used to sequence the genetic code of the virus, and led to the discovery that that was not just Spanish flu, but it was specifically an H1N1 virus that really changed the course of public health moving forward. And I think that's just a small example of the value of this remarkable repository. We've had a partnership with the Defense Digital Service that's been incredibly productive and helpful. We're so helpful. They have truly served as a SWAT team of nerds to swoop in and to help us establish the end-to-end process of digitizing these slides, which we think is, we know that we wouldn't be where we are without them, but they have helped us define, again, the end-to-end process, which I think we're going to talk a little bit about today, so I won't go into that too much, but needless to say, it's has a lot of different specific aspects to it that require technical expertise. I view artificial intelligence as the ultimate team sport because nobody has all the answers, but collectively we can get from here to there, and that's what I feel we're doing. It's just that's what really gets me very excited, is the potential to really leverage this resource in order to serve. And when I say serve, we have an intense passion to serve not just the military, but also for the greater good. Thank you.
Here's what I'm passionate about. I am a big fan of science, and I'm a big fan of the use of data to do big science. After all, I have been involved with the Genome Project almost since its inception. But I am also aware that there are a lot of people in the public who don't trust science and who are skeptical and who feel like they have either been misused or left out or mistreated or a variety of other adverse consequences. I therefore am completely committed to the notion of thinking about how we can develop the ways to do science in a way that is accountable to the public, that is respectful of the interests of individuals, that avoids mistakes of bias because of lack of representation, and many other issues with this. So with that passion, coupled with the real, I suspect, unparalleled power of this particular set of data, I just think that the idea of being able to sort of help develop a system for use and oversight that makes people feel secure about whether their interests are protected, whether the tools that develop actually work for them, is an unparalleled opportunity. That's why when I was asked to participate in this project, I was eager to try to help. I know this is going to be an ongoing effort to try to make sure that the interests of the public are maintained, but it is a totally worthy endeavor.
I'm passionate about modern software development practices, being able to move at the speed of thought. However, I've done this in private industry for my entire career. I was looking for something more substantial, something of a generational value, not necessarily just a monetary one. And when this project was presented to me, I think this is a generational good. This is something that will outlive me and outlive my efforts and probably have little resemblance to whatever it is we're creating right now. But to be able to participate in it and participate in it with these people at the top of their field that I probably would have never encountered in my very small island of software engineering colleagues. This is a unique once in a lifetime experience, and I want to make sure we do it right, we do it responsibly, and we do it ethically. There's plenty of vendors, there's plenty of companies, there's plenty of people that are more than willing to do this and extract a pound of flesh for us in the process. And I have a strong conviction, especially at this point in my life, to serve and actively try to improve the government and the country in which I live. And I can't think of a better place to do it than here.
My background is in computer science and machine learning, and I'm really passionate about being able to use data and putting in a lot of machine learning and computer science expertise to improve patient care, to make diagnosis available in low resource settings, and particularly in settings that might be hazardous conditions, and particularly important for the military, places where we might want to make diagnosis immediately, like during surgery. This resource is of immense value for that, the kind of models that can be built. It's very easy to build models for cases for which you might have a lot of data, common conditions, but this resource also it's just so large that you'll eventually find a lot of cases for rare diseases, and bringing that kind of diagnosis to lower source settings and having the rare diseases built into the model are of just immense value.
Stephen, I know that DDS has been partnering with the JPC, as Colonel Moncourt just described, since about April of last year. Tell us a little bit about kind of like what's happened in that time frame and what's been accomplished.
With this particular project, this is a little different from what DDS has typically done, in that we're doing something greenfield, and it was not very well defined, and it has sort of blossomed out into things beyond technology, which is why we have this broad selection of experts in their field on this call, because it was not just a software implementation anymore. There are ethical concerns, there are legal concerns. There's engagement with the public, there's patient advocacy, there's a lot of things wrapped up, and what would we encode the software to do or not to do that transcends just the technological aspect. And DDS is kind of perfect for this, because we bring in a lot of people from private industry, and it's not just programmers, right? It's a broad swath covering pretty much every discipline you can think of, that if you were to build a startup, and every type of role you would need is represented at DDS. So you put that together with sort of the nebulous greenfield problem that you have at the JPC, and that has made a very good marriage of interests. What DDS usually starts with an engagement is something we call a discovery sprint, where we get a small collective of people of broad proficiencies within DDS and engage with the people that have the problem, from issues the users are having to issues the data is, or what you need an end state to be. This along with like just sort of some discovery, asking a lot of questions. This is pretty complex subject matter specific software, so we weren't going to write this from whole cloth. We found some vendors to fulfill some of these requirements for the reverse image search, for indexing the slides themselves, for integrating with any sort of metadata that we will eventually use once we have discovered the ethical and proper bits and pieces that we could use. And additionally, we had to select a partner to do the slide scanning. It turns out Johns Hopkins University is quite good at this. Essentially, they scan the slides at an extremely high rate with some automated hardware. They send it into our cloud instance, and it goes through a process of ingestion and indexing, such that you can select and find slides. And with an additional benefit of being able to do something akin to a reverse image search, such that if a bench pathologist found something interesting and they were looking for something similar, if it's a needle in a haystack situation, the JPC probably has it. So with a reverse image search, they could use their digitized data and find things that are analogous inside of the JPC's data set, and possibly speed up a secondary consult there.
Dr. Mahmood, we've heard about the Joint Pathology Center and this modernization effort as a way to sort of help solve some of the most pressing challenges that are facing pathologists. So I'm wondering if you could kind of tell us in a little bit more detail, like what are some of the challenges in pathology today that we hope computational pathology and machine learning, leveraging a repository like the JPC, could help solve?
So one of the major challenges in pathology is reproducibility. It has been shown by a number of studies, very recent studies, that there's large intra-observer and intra-observer variability among pathologists in making diagnosis. And the cost of misdiagnosis can be very high depending on the disease. Computational pathology really has the ability to standardize the diagnosis and assist in making a more reproducible diagnosis and eventually improving patient care. The second challenge is identifying morphological markers that would be associated with response and resistance to treatment. A lot of the markers these days, biomarkers that predict whether a patient would respond to treatment or not, are based off of genomics, but not all patients get genomic testing, and such testing is often comes into play later in the process of the course of treatment. Being able to identify markers or from conventional pathology images has the ability to administer relevant treatment early on. The third one is really to enable pathology diagnosis in hazardous situations and in places where pathology expertise might not be readily available. Machine learning and deep learning, modern artificial intelligence tools in general, they are really data hungry. So they require a large amount of data, and they really have the ability to learn from historical data and identify common information across that data to make better decisions for the future. So that these models are basically built on historical data, and the JPC offers like an invaluable resource in that regard, because it's the largest repository in the world. So digitizing all of that will enable us to build models at an unprecedented scale. It has been shown that these models get better and better as more and more data is used, and just trying to answer some of the unique challenges associated with rare diseases, some of which might have a much higher representation at the JPC in comparison to other large repositories.
So you brought up one of my favorite things to talk about, data. And I know that introduces a host of issues, which Stephen kind of referenced as well, around data security and data privacy and sort of ethics in data science and machine learning. So I want to turn to Dr. Clayton. So Dr. Clayton, you're an internationally respected leader in the field of law and genetics. I guess just to start with, tell us about kind of how you got involved in this effort with the JPC.
Well, the wonderful answer to that is that they asked me to join and to advise them on this. And for a couple of reasons, I was absolutely thrilled to do so. First of all, I've known about this collection for many, many years. And I have some sense about how valuable it is and has the potential to be. And for the reasons that Dr. Mahmood has said, digitization is going to make it much more valuable. So that I'm excited about that. The other thing is that I've been working for decades on thinking about how to collect data and use it for research in a way that the public finds acceptable. So thinking about how to exercise a stewardship over these data and over these tissues in a way to maximize their utility for research while respecting the individuals and interests of the people to whom they pertain was a project that I just was really eager to get involved in.
Tell us a little bit about what some of the potential pitfalls are when we're talking about adoption of things like artificial intelligence in medicine.
Well, we already know what some of the issues with artificial intelligence are. One is that they may be trained on the wrong data set, so that you may come up with predictions that actually aren't accurate. That's a big one that people talk a lot about. It's also really important, I think, in these days of data collections, about the repositories being transparent in their actions and telling the world what they're doing, so that if someone wants to know, they can find out. That turns out to be really important. And the third issue is protecting the interests of people who provided the samples and the data that are in the repository so that they are not re-identified in most cases, and so they are not harmed by the presence of these data in this repository. I will say one thing here, that when I joined this group, I was thrilled to find out that the concerns that I have were already held by Colonel Moncourt and many of these others. And so we could really have a frank conversation about where the potential pitfalls lie so that they can be avoided, and to ensure that the value of this resource, once it's done, is going to be widely appreciated.
I'll jump over to Colonel Moncourt. I guess, is there anything that you want to add to that in terms of kind of some of the challenges that Dr. Clayton brought up? Like, how is JPC thinking about addressing them?
I have to say that we're completely in lockstep with Dr. Clayton, just in her views of the potential risks and also the potential benefits. And so I think that we've taken that very seriously as one of our highest priorities for this digitization project. I think that the Department of Defense has really helped us out because they have developed 5 principles of ethical use of AI. And so they are they're foundational to any efforts that we take. And I think that we recognize very early on that we need a resource governance policy. We think that that's really the best way to mitigate some of these risks that Dr. Clayton mentioned. And so I think that that's something that's currently under development and that we're very much looking forward to, because it can help us address all the different aspects of what was described: data, the privacy of the data, the security of the data, operational security for the military, and all the things that go along with that.
One question I actually wanted to kind of go back to was to hear, Stephen, as you were describing, who DDS is and what we do and the work on this project. I know that you were working in sort of private industry before you came over to the Department of Defense and Defense Digital Service. Could you share a little bit more about what's been sort of unique about working on this project in government and how it differs from some of your experiences in industry?
First of all, the project itself is unique. It's a melding of cutting edge machine learning as a platform applied to pathology, which pathology images are huge. They're 500 to 1,000 times bigger than the kind of images you would do with a reverse image search on Google. So there's like particular technical hurdles to be solved there, just to have parity with like just looking for cat photos on the internet or something. It's just not quite as simple. Besides the technological aspects, I came from big tech where you would just make a product on a demand and you would move fast and you would hand it off and you would go on to the next thing. There's a lot of things that create circuit breakers in government, sometimes for good reasons, sometimes just for reasons of this is just how it's always been done. So I mean, in this particular project, it's not just government, right? So there's particular medical rules and protocols and data safety. You also have to cross that with things specific to the government and things specific to the military, and the confluence of all of those things, and how do you produce anything out of that, and this was one of the biggest particular challenges. Also, there's the issue of transition. And that as DDS members, we're not going to support this software forever. In fact, we're term limited employees, which keeps us out of the politics. And a lot of us are here for passion to do some government service. So there's no angles for us.
I think that the reverse image search that Stephen mentioned is incredibly powerful. And I'll just share an example. So within the JPC repository, there have been new diseases that have been discovered, several new types of things that are now part of established classifications of disease by the WHO by the World Health Organization. And those diseases were discovered through just pure brute force in that some of our experts would identify a unique case, they would set it aside, and they would think that it had the possibility of being a new disease, but they had to have multiple examples. And so in one case, one of our esteemed pathologists, Dr. Charles Davis, in genitourinary pathology, he discovered a unique kidney tumor in a young male. And over the course of 30 years, he collected, it took that long to identify over 20 examples of this particular case, at which point he did determine that it was a new disease and named it renal medullary carcinoma. And so I think that which went on to be discovered to be genetically unique and truly its own disease. We think that we can really accelerate this process of discovery through techniques like reverse image search. So reverse image search allows you to look at a slide, identify every slide that gets digitized. It will identify 15 unique looking areas and assign a low memory barcode to them, so that if a pathologist is then identifying a new thing that they think is really interesting and could be a new disease, they can then say, well, show me everything that you've digitized that looks exactly like this focus right here. And it will take that 30-year process and condense it and bring all those cases to the forefront so they can be more readily reviewed and for to really augment the discovery process. So I'm particularly excited about that capability and what it means, because I think that we all recognize that there are new diseases to be discovered that are locked within the repository. It's just up to us to identify the tools to mine those and to bring them to light and characterize them.
Colonel Moncor, I'm hoping that you can kind of tell us a little bit about kind of what's next. And, obviously scanning 55 million slides is an ambitious goal, but that's not the end in and of itself. So tell us kind of what happens next.
Sure, I'm happy to do that. So I think that it's true that we're really squarely focused on the digitally transforming this repository, and it's an enormous task. Some have likened our warehouses to those seen in Raiders of the Lost Ark, where there's just boxes and boxes and stacked high, and that's true to some degree. So it's a big task. I think that once we get to the point where the repository is really digitized and accessible, we really want to focus on partnerships. And actually, we're even beginning that work now. We'd like to form partnerships with academia, with companies, with philanthropic organizations, and that we want to partner with people who share our priorities and our sense of ethics, but also have the tools and the skills to really make the most out of this data. And we think that's really where we'll have the greatest impact from everything that we're doing.
Dr. Clayton, throughout the conversation, we've heard kind of all of our panelists talk about the huge potential that's in this repository. But I can imagine that some of our viewers, as they've been listening, maybe have developed a little bit of a concern about all of this data. How is it being protected? How are we thinking about data sharing and ethical use of this data and the resources in the repository? What would you say to try and alleviate this worry that might have developed?
Well, that's a great question about how I could allay concerns. One of them is that the project has already been very proactive in thinking about security and thinking about governance, where I think most of the action is with regard to these issues. We do have some loopholes in the law that don't provide quite the protection that I think we would want, but it is by no means unique to this. And I think that the commitment to stewardship that's going to be exercised by the JPC ought to be incredibly reassuring. And they have tremendous incentives to be thoughtful in how these data are used and to how the interests of the individuals are protected. And so I think this is going to be a city on the hill. This will be a place to go to make sure that you are doing it right. And so I think the fact that they've reached out so early and have been so open, and the fact that, as Colonel Moncor said, we were already aligned before we started, I think that should be enormously reassuring. And I think, frankly, the issues that are going to arise outside the JPC, not inside it.
in conclusion, I would love to hear from each of our panelists something you wish you'd had the opportunity to share, but I didn't think to ask you. So let's start with Colonel Moncourt, and I will loop around from there.
I think that one thing that I'm excited about is that all the cases in the JPC repository are diagnosed by subspecialty-based experts. Many of whom are really some of the most renowned pathologists of their time, and so using this particular group of cases as a training set for machine learning algorithms is particularly exciting because it really exports that expertise to those that are using the algorithms. In simplistically stated, I think that I like the idea of, if I were a pathologist, these algorithms are just like having an expert JPC pathologist look over my shoulder or look at the same microscope with me and say, hey, look at this. What do you, I think this is this, I think that this is the correct diagnosis. And I think that that's enormously powerful. Our model has been historically to bring all those physical slides to the Institute to centrally review them and provide a diagnosis, which we send back. But this is really exporting the expertise of the Institute, this historic institute, out to doctors to empower them to do a better job at the site, at the point of care. And it's very exciting to me. I think it has enormous potential.
So just to convey to the audience that how valuable this resource is, to give an example, the Cancer Genome Atlas, or the TCGA, which is the current largest open source resource of pathology slides, has about 30,000 slides, and 10,000 of which are diagnostic slides, another 20,000 are for infections. And that has really led the entire field of computational pathology. Over 90% of studies in computational pathology that have been published to date have used the TCGA in one form or the other. And there are tens of thousands of articles. The entire setup of everything that's been done in this field is based off of that. And if we can do that with 30,000 slides, what we can do with 55 million is just sky's the limit. So I'm really, really excited about this repository. My team is really excited, and I know the community in general, the computational pathology community in general, is very, very excited.
My closing thought, sort of hinted at, but I really think I need to put a point on it. And as others have mentioned, there's enormous value in this collection of data. There's enormous value in being able to contribute to the health outcomes of service members and to do a great public good. And I don't think I can stress enough that both the JPC and the DDS feel strongly that this is not a resource to exploit or otherwise monetize. There are literally companies beating down the JPC's door to make money and take the shared good and privatize it as their own IP. And we need to remain vigilant about the judicious use and sharing of this data for the public good.
Stewardship is going to be the guide word for this, to make sure that the use of these data and images and the products that are developed as a result therefrom really need to be used to benefit the public at large, and of course the military in particular. And I am very enthusiastic about that.
Awesome. So that's our panel for today. To our viewers, I want to say we appreciate you. We hope you found this informative and helpful. And to our esteemed panel, Colonel Moncourt, Dr. Clayton, Dr. Mahmoud, Stephen French, thank you so much for joining us today. We know that you have a lot going on in your busy schedule, so we appreciate your time. And thank you for everything that you're doing to improve medicine, not only for our service members, but also for the population at large. So thanks everyone, and enjoy the rest of South by Southwest.